After discussing and understanding the general architecture, it's now time to focus on how to implement the different concepts. As mentioned before, this is a stateful case where the two bulbs are stateless, and they are only supposed to notify the common parent when clicks happen. This is achieved through a reference to a callback method received from the parent when they are created. In this scenario, the parent plays a key role, as it is the stateful component in charge of managing the two different state regions. This means it handles the state elements, in this case active 1 and active 2 for the two bulbs, and it is also responsible for implementing the callback called toggle, which is then provided as a reference to the two children. Additionally, it is responsible for calling setState to ensure that as soon as the state changes, the UI is properly rendered and kept in sync. So now let's go back to our example. The initial part is more or less always the same. We have the imports and the main function that runs the app. In this case, we start with an initial stateless widget, which we tend to call myApp. The build method is also standard, as it returns a material app that contains a scaffold with a simple app bar. The new part here is that the body is set to a parent widget. This parent widget is the stateful component in charge of managing the state of the child components. The structure of a stateful widget is always the same. The widget itself overrides createState, while the corresponding state class handles the state management. In this case, we consider two state elements, two Boolean values, active 1 and active 2. To ensure that the two bulbs are never on at the same time, we initialize one to false and the other one to true. For the same reason, the callback toggle, besides calling setState, simply negates both values. So, whenever one of the two bulbs is clicked, their values are inverted. The build method then uses a center widget that contains a column, and the column includes the two bulbs. We also use a size box to add some space between them. Note that the constructor for our stateless widget bulb requires two parameters. One called state, whose value is provided by the parent. The first bulb is initialized with active 1, and the second with active 2. Both children also receive a reference to the same callback method, which is toggle. Now, if we move to bulb, which is the last part of the example, we can see that it is a stateless widget. We need a meaningful constructor, so besides handling the key, we include two additional required parameters, clearly called state and toggle, since we do not want default values. These two attributes are defined in the class with the same names. State is a Boolean, while toggle uses one of the predefined types we discussed, called void callback. We use void callback because the function does not return any value. Looking at the build method, we again use a center with a column. The bulb contains both the icon itself and an elevated button used to control it. To initialize the icon and its color, we use the ternary operator based on the value of state. We show a filled light bulb or an outline one, depending on whether the state is true or false, and we use yellow or gray as colors. We also set the size to 80 to make the bulbs clearly visible. The elevated button is something we have already seen. Here we simply style it using elevated button style from, setting the background color to blue-gray. For the onPressed callback, we use the value passed from the parent to the constructor, namely toggle. Finally, the child is just a simple text widget styled with white color and a font size of 20. Another slightly different case is when, instead of having two bulbs with two switches, we have one bulb controlled by two switches. In other words, the single bulb can be controlled by either switch, so when one is clicked, the state of the bulb changes. What's the difference? The overall organization is still the same. The parent widget remains stateful, since it's responsible for managing the state of the bulb and coordinating the behavior of the two switches. This means that the parent state now has just one attribute called isOn, which is initially false. The callback toggle simply negates this value, so if isOn is true, it becomes false and vice versa. The build method is quite simple. We use a column with three elements, two switches and a bulb. The two switches are not just simple buttons. They are widgets that receive a parameter called toggle, which is the callback provided by the parent. Finally, we have the icon representing the bulb. It behaves as usual. If isOn is true, we display a filled bulb. Otherwise, we show the outline version. The color is yellow or gray, respectively, and the size remains the same. To conclude, we finalize MySwitch. MySwitch is basically an elevated button, styled as before, with a background color set to blue-gray. The callback through the onPress parameter is initialized using the toggle function received from the parent, whose type is once again void callback. Finally, the child is a simple text widget displayed as before with a font size of 20 and white color. After considering the complexity of state management, we now need to move forward and address a very simple concept that is common to almost any software development. Whenever we conceive a new piece of software, we usually don't start from scratch. Instead, we want to reuse external components, libraries, modules, or packages. In Flutter, this means we can reuse external packages that provide the features and functionalities we are interested in. Be aware that, in general, anyone can create external packages. For example, each developer can create their own. Flutter and Dart, however, come with a special official package library that we can import. Besides importing these packages into our project, we must also remember to add them to the project's configuration. In other words, we need to modify the file called pub_spec, which is the file that defines the key elements of the app.